Hello, everybody. Today we will have Dr. Alan Brown and Suzie Ogilvie will be presenting for you. Thank you, guys.
Thank you. Okay, good afternoon, everyone. My name is Alan Brown. I'm the Chief Technology Officer of Aptitude Global. Aptitude Global are a data and AI consultancy. We are based in the UK and also in Spain, and we specialise in regulated technology in the financial services and the legal sector. Delighted today to be joined by Suzie Ogilvie, who's a partner at Ogiro Risk and also a global sanctions expert. And we're going to explore knowledge graphs in action, how we identify sanctions circumvention in a complex global landscape. So I'm going to pass you over now to Suzie, who's going to talk us through some of the challenges that we're trying to address.
Good afternoon, everyone. I thought I'd open this session with a question for you, and that question is really sort of sets the scene for the discussion today. And this relates to what happens to a person who is subject to sanctions, or whether or not a business is subject to sanctions. And effectively, the question is, what do you think a person would do if they suddenly become impacted by sanctions, or the business becomes subject to sanctions? Do you would they firstly hope that their customers, their suppliers don't actually notice this? Would they look for ways to perhaps get around that by transferring ownership, or perhaps using other parts of the world in order to look for business opportunities elsewhere? Now, these are questions that often come up for businesses when they're trying to comply with sanctions. And one of the issues that is commonly felt is that any providers of data only really cover the first option. So we're going to talk a little bit about the challenges that arise in sanctions compliance. Firstly, what businesses suffer from is the volume of sanctions. There's been a huge marked on increase in the number of sanctions measures. So you will see at the bottom of the screen that there's perhaps over 70,000 designated persons to be considering as part of your business operations. There's been a 370% increase in sanctions measures since 2017. And if we just look at the past couple of years, there's been over 2,500 Ukrainian sanctions. The next issue is the pace of change. When sanctions are issued, businesses are expected to respond very, very quickly. And there are situations in which perhaps they might find themselves subject to action, regulatory enforcement, if they don't react immediately. To add insult to injury, then you have complex programs where the provisions can be complicated and difficult to apply in practice. One particular issue that businesses struggle with is the requirement to determine ownership and control of a business in order to understand whether or not there is a sanctioned person in the ownership or the control chain. And this sort of brings us to the sanctions circumvention point as well, where many individuals who find themselves subject to sanctions actually transfer ownership to below the 50% threshold for ownership. They also think about putting in place complex structures to obfuscate the ownership. They might also transfer to proxies as well, despite retaining control. Or they might use known circumvention hubs, so countries in which it is easier to do business where there's no sanctions apply, and they can perhaps use those hubs through which to do business, for example, new trade deals. So these are some of the issues that arise in terms of sanctions compliance. Just to talk about some examples. These are actually examples that have arisen, and businesses have to think about, in these circumstances, obtaining data that will help them make an informed decision as whether or not there is actually an issue in sanctions compliance, or whether or not they can actually get the comfort they need that there has been a real change such that they can continue to do business. So these examples, there was a telecoms company where there were various transfers made at various levels to transfer shares to just below the 50% threshold. The question then for businesses is to really understand, well, was that an arm's length transfer, and can I continue to do business with that company? Similarly, there was an investment company where actually the transfer of shares from designated persons and sanctioned persons was transferred to an employee. And the question then arose, was that employee actually running the business, or was that employee taking instructions from the original shareholders and sanctioned persons? The final one is a shipping example where circumvention hubs were used to transfer vessels so that oil sanctions could be circumvented. So these are just some of the examples that businesses have to think about. And we're now going to talk about why the traditional list-based screening falls short. I'll hand over to Alan again.
Thank you, Susie. So current screening technologies have quite significant limitations, but first we have to understand how they work. What they effectively are doing is they're comparing names, your client name, your counterparty name, against lists of designated persons. So they're gathering all of the sanctions lists and comparing a name against a list. Now, that suffers from quite significant limitations. For example, different spellings between your internal client data and the third-party data, the sanctions list, transliteration, so the comparison between, for example, if you've got your data in English, but the sanction name is in Russian, different cultural naming conventions. We have no control over the fuzzy matching logic that's been applied. This can cause excessive false positives, or it can cause mismatches. We see instances of common names. I seen a sanction this morning when I was looking at one of the sanctions lists from Iran, which sanctioned a very common name. I think it was David Owen. Now, it had no date of birth, no address, just the name and the country. Now, that's going to create false positives with many directors and owners of companies in the UK with that particular name. So these screening tools have very limited tools in their own arsenal in order to be able to detect those. We also suffer from data quality issues. Your internal data may be missing dates of birth, nationality, etc. And they're absolutely not designed to be able to cope with evasion tactics. And we know through what Suzie has just described here, that designated persons will seek to avoid detection by either hiding their ownership or hiding their identity. And these tools simply are not structured to be able to identify these risks. So what is a better alternative? Knowledge graphs. So knowledge graph is a design pattern for storing, organizing and accessing interrelated data entities, including their semantic relationships. So the semantic relationship part is very, very important here when we consider sanctions. If you look at the legal and financial sector and we think about the concepts that we deal with on a daily basis, clients, counterparties, adverse parties, ownership chains, supply chains, etc., and all the third-party risks that we have to navigate, sanctions, ESG, adverse media, PEPs. This is highly interactive, interrelated, interconnected data that traditional databases struggle to handle, but graph databases, however, are uniquely positioned to be able to support this. So how would we build a knowledge graph? So we start by defining the model. And if we think about this in the context of sanctions, we think about the key entities, the things that we engage with on a daily basis. So companies, vessels, accounts, addresses, persons, sanctions, etc. And then we think about how do they relate. So we can start to model this. We define our model. Anybody can do this. This is a simple activity. People own companies. They are directors of companies. People are sanctioned, companies are sanctioned. All of a sudden, we're starting to define, quite a simple graph data model. So we're on the journey to be able to building a knowledge graph. The next step is we always need third-party data. For sanction screening, we need to enhance our internal client data and counterparty data with the ownership chain. So we need beneficial ownership data. We can get this from various companies that capture this. We can get it from registers like the Companies House Register. Like Dun & Bradstreet, etc., have very comprehensive data sets here. But we also need the sanctions list. We can either gather them independently, we can go directly, or we can go to data aggregators such as Open Sanctions, which will demonstrate in today's session how we use this resource. And we bring this together into our graph ultimately, but we have to standardize, clean, and very importantly, resolve the data first. The standardization process it happens between our bronze and silver layer. So this is a medallion architecture. It's fairly typical in terms of a data architecture. Our bronze layer is typically raw. So we take our data from our internal systems, our third-party data sources, and we dump it in the raw layer, in our bronze layer. We then have to start to transform that data into our standardized data model so that all the data sources look the same, so that they can then be applied into our graph database. And a very important tool here is entity resolution. I see entity resolution as a data integration tool. Many people see it as a data deduplication tool, but I think entity resolution is critical for linking your internal data and your third-party data and identifying when they're referring to the same person or the same company or the same vessel, the same entity. And we embed this within our integration layer prior to building our silver layer. And from here, we can load the data into the graph. You do have a gold layer. Typically, that's consumption layer for reports and analytics, and potentially for consumption into your machine learning models or the results of your machine learning models. But let's just focus at the moment on the data moving from silver, because we then push this data into the graph. We've got the conformed entities. We've identified our nodes and our relationships, and we'll use tools, such as Spark connector, Databricks connector. I'll demonstrate the Databricks connector today. Neo4j drivers to load the data into your knowledge graph. From this point, we still need to do risk scoring, alerting, visualizations, investigations, etc. So you need additional tools on top of your graph to support this. Neo4j's graph data science library is very powerful to help us with risk scoring and identifying additional attribution to support our alerting. Linkurious Enterprise is a tool that I'll demonstrate today that we use for investigation, alerting, and visualization of the graph. And you can also feed your graph data back into your data processing layer, where then you can further augment that through machine learning processes, etc., to further enrich your models. So we've got an end-to-end process here, and I'll demonstrate how this works in practice as part of our demo today on how we would approach building a knowledge graph. So before I jump into the demo, I do want to just highlight again why graphs are uniquely positioned to help identify sanctions risks. When we're only looking at the client themselves, we have a very limited view of the data. We can compare their attributes, their name, etc., their address, but we can't compare and we can't identify their connections. We can't look at the actions, the activities that they have performed, who the people they engage with. And for that, you need a graph-based technology, you need graph analytics. And it helps us identify those that are deliberately trying to hide. And this is where sanctions screening tooling really falls short. For example, we can identify ownership transfers that were close to sanctions timing. Again, I'll give you a demonstration of how this looks in a graph. We can use community detection and pathfinding algorithms to identify overly complex structures that obfuscate ownership. We can apply anomaly detection to identify ownership transfers. We'll talk about entity resolution a lot today in terms of how we compare multiple data sources to identify deliberate misrepresentation of data. We can even find shell companies by using community detection algorithms. So there's a huge number of tools in our arsenal to identify these risks, and these just don't exist in your current screening technologies. So I'm going to jump across now to a live demonstration, so hoping we don't have any issues here. So what you can see on the screen at the moment is Linkurious Enterprise. So Linkurious Enterprise is an alerting, investigation, visualization tool that's directly connected into the graph. And the first thing I'm going to jump in is show you is one of the alerts that I've created. An alert is effectively Cypher queries that are executed against the graph database on a scheduled basis. And the results of those are consumed into a case, which can be investigated by a user of the tool. Now, Suzie mentioned a circumvention typology earlier, whereby designated persons will transfer their assets either in advance of or just after they've been sanctioned to avoid detection. They may still, for example, control ownership of that, but just not directly and just not on paper. So a typology that we can search for in the graph is asset transfers within 3 months of the sanction. And here's just an example of this. Oh, actually, in fact, let me just open one of the cases first. So this one here is Alisher Usmanov. And this is an example of the graph. And let me just talk you through the model so you can see how the data is structured. So we've got a record here from Companies House from Alisher Usmanov, and he is an owner of Curzon Square Limited. And we can see this ownership record had a end date of the 6th of April 2022. Now, these links here are resolved to this entity person, and this entity person are possibly the same as, this is our entity resolution process. This is how we're linking the Company House record to the open sanctions record. And we need this process to tell us whether this person in Companies House is the same as this person in open sanctions. And if I look at this person in open sanctions, I can see here one of the sanctions record has a start date of the 5th of April 2022. That's within a very short time frame of the ownership sale. Again, I'm not suggesting this is real data. I'm not suggesting this is anything untoward, but it's something that we would look to investigate because it's a typology of something that potentially could be suspicious. When we perform entity resolution, we do want to validate that the match was accurate. So what we can also do here, I've deployed a plugin on Linkurious that queries the Sensing API. Sensing is the entity resolution tool that we use. Sensing is a fantastic tool. It's plug and play, so we plug it into our architecture. It's real-time capable. We standardize our data towards a sensing model. It performs entity resolution, and then we can query the API to extract the results out into our graph. So, here's an example of us pulling the entity resolution results back from the sensing API. We can compare against the two records, and we can see that they matched on nationality. They had a very close name on their name match. They had a partial match on their date of birth because Companies House do not provide a day. And because of that, that's why we didn't have a fully resolved entity, a full match. That's why it came back as a possibly same, because we didn't have a full date of birth, which wasn't concrete enough. We can configure that if we wanted to change it. But most internal company policies are that you'd require the full date of birth in order to do a person match. And using this, we can then obviously further explore and gain confidence that we've got an accurate match through the entity resolution process. Okay, so in terms of the alert code, so again, just before I jump out of this into the next example, building alerts in Linkurious are really simple. Ultimately, if you can write Cypher, you can write an alert. This is what that particular alert looked like. It was finding directorships and ownerships, which you've seen in the graph. So people who hold the ownerships or directorships of a company, and through the entity resolution process, they are resolved to a person that has a sanction. And then we're comparing the start dates and end dates as to whether they are 3 months apart or not. And that's how that runs. And that's scheduled to run on every day at midnight. So very simple to build these alerts. That's looking at one specific case, but what if we want to learn more about the wider network view and actually perform some graph analytics? So I'm going to jump into Databricks now. So Databricks is the data processing layer that we have implemented in our architecture. This is deployed on Microsoft Azure. You can see here we've got a bronze layer where we're loading data in from various data sources. We've got a silver layer where we conform the data. Down this left-hand side, we've got a load processes where we conform it into our target model structure, which is defined by the schemas at the top there. And I will just go into a little bit of detail about the load to sensing process, because I think it might be useful to see the Databricks connector and how simple it is to load data from Databricks into Neo4j. So the first thing we do is we set up our configuration to the graph database. This is stored in Azure Key Vault. Our credentials are stored in Azure Key Vault. So we extract out our URL, username, password, etc. And we set up the connection to the database. And then we use this within the process. First thing we'll do is load the nodes. So you load the nodes, then you will load the relationships. The syntax is very simple. So you populate a data frame using a Spark read from the silver layer table into the data frame. From the data frame, we just pass in the connection information. We specify the target label of the node that we want to load. So this one's loading organizations from the silver table company. And we specify the keys, so that identifies the uniqueness of the node within the graph. A write strategy and save. So it's a couple of lines of code, and we can then start to process and load our data into the graph. Relationships is just as simple. Again, we populate a data frame with the details of both the source and the target node and the properties on the relationships. We specify the relationship type, and we specify the source labels, the target labels. So person is an officer of an organization. There's the person keys, and there's the organization keys, and then we simply save that. So a very simple process to load the data into Neo4j. So I'm just going to show you how we can use Databricks before I go into the next example, which is looking at the wider graph and performing graph analytics to identify risky nodes within the graph. There's a couple of things we might want to do in terms of creating new attributes, creating new features within the graph that we can use for graph analytics. So the first one I'm going to create is a sanction count. So this is the count of sanctions that are in any person or organization's network based on these relationship types, right? So there's a series of relationship types and within 7 hops. So we're basically starting at a person or an organization node, expanding the network out by 7 hops and counting how many sanctions we find. And then we're going to store that as a property on the person or organization node. So this gives us an additional attribute on that person to try and identify, are they potentially risky? So this is just a query just to run that shows the sanction count for entities in the graph. The next thing that we always should do as part of a sanction screening process is to evaluate the relationship types and try and give them a cost or a strength. You could be 2 hops in a graph from a sanction. You could have 2 companies or 2 hops from a sanction in a graph. They're both 2 hops in the graph, but those hops may have very, very different meanings. So my 2 hops could be that I'm possibly related to a company, which is possibly related to another company because we share an address. Now that address may be a formation agent, right, where there's 10,000 other companies that share that address. So actually my true distance to the sanction is quite far. However, if the 2 relationship hops were I'm the owner of a company which is the owner of a company which is sanctioned, then although they're both 2 hops, they're actually very, very that second one is much, much closer in terms of a risk to a sanction. So we have to go through each of the relationship types and set a cost attribute. So we're saying if you're directly sanctioned, then it's 0. If you're resolved to, i.e. you're the same as, it's 0, etc. But if you're possibly related to, we can apply a higher cost. And then that allows us to, to use this in a later query, which is the shortest path algorithm. And I'll go through that in a wee second. So the next thing I'm going to do is to create a couple of labels in the graph, which are going to aid my next query and make it simpler and simplify the syntax. So the first one is I'm going to apply a label to nodes that are entity nodes in the graph that are sanctioned. So again, where we have a node that's resolved to another node which has a sanction, then we will set that node as a sanctioned node. Okay, so again, that allows us just to quickly query any node in the graph without having to repeat this pattern in the query. Again, you'll see how this simplifies the query in the Linkurious alert that I'm about to demonstrate. The next one is just where we did those sanction counts greater than 0. I'm just going to apply a sanction risk label to person and organisation. Appreciate the naming convention here is not the Neo4j standard one, but it helps me differentiate labels that I've added for, to simplify my querying versus true labels in the graph. So next thing I do is to create a graph projection. So this is a graph projection effectively queries the graph and based on a definition of a set of entities, so labels, so persons, entity persons, organisations, the sanction risk label that I've just created, and also the relationships. So, and creates a projection in memory of that graph. So it's a subset of the real graph, the physical graph, that we then hold in memory, so we can then perform graph analytics, for example, some graph data science queries against the projection, which is obviously a smaller subset of the nodes in the graph. It's more performant, more memory efficient, and ultimately it's a more effective way of working. So we create the graph projection. We are going to run a query here first to identify the source and target nodes. And we pass the source and target nodes, the unique set of source and target nodes, into this Dijkstra shortest path algorithm. What we're trying to do here is also pass in the cost of the relationship types and calculate for each source and target what the shortest path is between those two nodes in the graph, and accumulate the overall cost of those graph traversals. And then on each node, we want to store the minimum cost. Okay, so how close are we to a sanction? So the very, very closest sanction in our network will be stored, the cost of that traversal will be stored on the node as a new property called distance to sanction. Okay, so only a couple of minutes left. I'm going to jump quickly in and show you what that looks like in practice. So this is the query. We run a quick pre-processing step. This is a new feature in Linkurious for pre-processing. This will execute automatically before the query itself. Before the alert itself. We're using our new sanction risk label, so match sanction risks, where we have a distance to sanction populated, and this is a weighted calculation to create a sanction risk score. So we're more heavily weighting the closeness, so how close we are in the graph. So applying 100 times the closeness score, which should be very small. So if I'm next to a sanction, it should be 0, and 1 times the sanction count, and then we're adding them together to create a sanction risk score. So when I run this, and this query is just going to grab the top 10%, when I run this, you can see at the dashboard the highest weighted sanctions. Again, if I just sort this by the top, then you should see the nodes in the graph that have that are the combination of the closest to a sanctioned entity and have the largest number of sanctions in their network. So example here, Iranian Oil Company UK Limited. This is if I just run one of my pre-saved queries here to find sanctions in my network, this is going to do a graph traversal to find sanctions in the network up to 9 hops. There should be a lot, hopefully. Here we go, right? So 680. So we've got a large number of sanctioned entities here. But when we actually zoom in on Iranian Oil Company, we can see that it's got a distance to sanction of 0. It's got the sanction count of 362, and that distance to sanction is 0 because it is resolved to Iranian Oil UK Limited, which was resolved to an open sanctions record, which is directly sanctioned by the US. Okay, so I think that's everything I've got time for in terms of the demonstration today, but hopefully what we've been able to demonstrate is the power of knowledge graphs and how they can significantly improve on current screening technology for sanctions to try and identify more complex cases of sanctions risks and sanctions circumvention. I'm happy to answer any questions.